Okay, for 1a, we're asked to find f of 2 first. So when x equals 2, f equals negative 3. So now I'm going to take that and rewrite it as g of negative 3, which the teacher did for us. So now I need to find g of negative 3. And when x equals negative 3, g equals negative 1. And that was a. For b, it's g of negative 1. So now I'm going to find g of negative 1. So g of negative 1 is 0. That means I next have to find g of 0. G of 0, if I go across zeros there, g of 0 is negative 3. F inverse of negative 1. So this is actually working backwards. It's asking when f is negative 1, what's x? So that would be 0. You're working backwards. All right, double inverse. So when f is 2, x is negative 3, so then it's going to ask what the inverse of negative 3 is. All right, when g is negative 3, x is 0. So it's a little tricky. So they want me to take the square root of x, g of x equals the square root of x, and they want me to reflect across the x-axis, so that's going to give me g of x equals negative square root x, then shift it 4 units left and 2 units upward, and that's where the opposite same is going to come in. I'm going to use that notation. So I'm asked to go 4 units left, so that would be negative 4, and then 2 units upward, 2, so it's going to be g of x equals negative square root x plus 4, opposite, same, plus 2. And that would be my final answer. And it matches up with the teacher. Find the inverse. So I'm going to rewrite this as y equals 2x over 1 minus 3x. And then I'm going to flip-flop the x values and the y values. And that's going to give me x equals 2y over 1 minus 3y. And here's the tricky move. I want to multiply both sides by the bottom of the fraction. So that's going to give me x times 1 minus 3y equals 3y. I'm sorry, equals 2y. The top equals 2y. Now I'm going to distribute that x across. So that's going to give me x minus 3 xy equals 2y. Now, do understand, I'm trying to solve for y. I'm trying to solve this for y. So I have to group the y's together. So that's going to give me x equals 2y plus 3xy. Now I have a y in each term, so I'm going to factor a y out. That equals x. Now the opposite of multiplying by 2 plus 3x is dividing by 2 plus 3x. So my final answer, this is my inverse. And the y is rewritten as h inverse of x equals x over 2 plus 3x. Number 4, difference quotient. So the first thing it asks me for the difference quotient is just plug a into that. So f of a is just going to be, wherever there's an x, put an a. So that instead of being 2x, it would be 2a over a minus 4. Then it says, do a plus h. So now, wherever there was an x in the original, I'll put an a plus h. So it's going to be 2 parentheses, because there's an x there, over parentheses, because there's an x there, minus 4. And in those parentheses, I'll put a plus h. Now I have to do a little arithmetic. That's going to equal 2a plus 2h over a plus h minus 4. So there's the first step. There's the second step. That wants me to actually do the difference quotient. And that's going to be a little tricky. So the difference quotient is this minus this. So 2a plus 2h over a plus h minus 4 minus that 2a over a minus 4. I don't know if you noticed, the difference quotient says f of a plus h minus f of a. However, I have to divide this whole thing by h eventually. So I have to remember to come back and divide this whole thing by h eventually. And yes, that's a little tricky. But first thing, let's go over old school adding some fractions, subtracting fractions. So if I have 2/7 minus 3/5, here's how I would go about just subtracting those two fractions. I'll put it at the big division bar, and I would do 7 times 5 on the bottom. Then that minus sign I would put on the top, and I would do 5 times 2 on the top left, and 7 times 3 on the top right. And I'm going to follow that pattern. I'm going to multiply the two bottom ones. I'm going to cross multiply over the negative, and I'm going to cross multiply again over the negative. But I'm going to keep that negative there. And it's going to be this quantity 10 minus that quantity on the right. So I'm going to follow that process here. So I'm going to put my big division bar, and in the middle I'm going to put a plus h minus 4 times a minus 4. And then I'm going to do a minus 4 times that. So a minus 4 times 2a plus 2h minus, and now I have to multiply this times this. 2a times a plus h minus 4. Now do remember, this is all going to be divided by h eventually. Then I'm going to simplify. I'm going to FOIL everything out and simplify. It's a lot of algebra. So when I have a binomial times a binomial, I like to do a Punnett square. when I have a monomial times a trinomial, I'm just going to FOIL that out. I'm going to distribute the negative. And then underneath of that, I have a binomial times a trinomial. So that's going to be a 6 squared punnet. It's just a lot of petty algebra. So let's see here. This is going to give me 2a squared, 2ah, negative 8a, negative 8h. Then I'm going to distribute this negative 2 across. That's going to give me negative 2a squared minus 2a squared minus 2ah plus 8a. So I'm going to simplify this and write this down all on the top. So it's going to give me 2a squared minus 8a plus 2ah minus 8h minus 2a squared minus 2ah plus 8a. Now I'm going to FOIL this out. That's going to give me a squared, ah minus 4a minus 4a minus 4h plus 16. Now if I look on the top, I'll notice I can start simplifying stuff. So the 8a and the negative 8a, they'll cancel out. The negative 2ah and the positive 2ah, they'll cancel out. The negative 2a squared and the positive 2a squared, yes, they cancel out. That leaves me on the top with negative 8h over a squared plus 8h minus 8a minus 4h plus 16. Now, this is all divided by 8. If you recall, in the beginning, the difference quotient is all over 8. So I did all my arithmetic, and then I put it over 8. So now, all I have to do is KFC this. This is technically h over 1. So I'm going to multiply it by 1 over 8. You'll notice this h and this h cancels out. My final answer is going to be negative 8 over a squared plus ah minus 8a minus 4h plus 16. And that's my difference quotient. So I'm just expected to find the equation for this difference quotient. And she has it laid out here. It doesn't really indicate that there's an arrow here, but I guess there's an arrow going to the left forever. And I suppose there's an arrow going to the right forever, according to her answer key. So just looking at this, I'm going to set up the equations and the domain restrictions. So for the first line, I notice if I were to continue in that same pattern, down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, it would take me through the y-intercept of negative 2. And it's going down 1 over 2, so that equation is going to be y equals down 1 over 2 x minus 2. And notice, it starts at a closed circle at negative 3, So the domain is going to be x is less than or equal to negative 3. And that's the first part of the piecewise. The second equation, I believe, is open circle 2 and open circle, closed circle they give us on the bottom one. So that's going to be y equals 1, 2, y equals 2, and it's from negative 3 over to 2. So x is between negative 3 and 2. And it let us know that this was an open circle. This equation, I noticed the slope goes up to 3 over 1. Up 1, 2, 3 over 1. So it's going to be y equals 3x. And then as I go down 3 over 1, that puts me at 1.5. I go down 3. Ooh, it's getting a little tricky. I'll figure it out. I'll just slide a little extra paper under there. And we can approximate it. It'll look good. So from here I go down 1, 2, 3 over 1. I'll go down 1, 2, 3 over 1. From there I'll go down 1, 2, 3 over 1. And that would put me at negative 1, 2, 3, 4, 5, 6, 7. And if I go down 3 more, that would put me at negative 10. And this graph goes from 2 to infinity. X is greater than or equal to 2. Ooh, she said negative 5. Let me see. Oh, yep, because these are only 1 unit. So that's not y equals 2. That's actually y equals 1. The scale is a little tricky. Let's see here. I go down 1 over 2. It's still negative 1/2. It's still negative 1/2 for that. It's still positive 3x. So that's my piecewise defined function. I'm going to have to answer some questions about this x cubed. Notice it's positive 2x cubed, so it goes down on the left. And it'll end up on the right. Has that nice cubic shape. The domain of any polynomial is negative infinity to positive infinity. The range is from the lowest y value, which is also negative infinity, to the highest y value, which is positive infinity. You want to know the increasing interval, so it's increasing from negative infinity all the way up to this x value of negative 1. So it's going uphill all the way to negative 1. Then it starts to go uphill again at x value 2. At that x value 2, it starts to increase again, going from left to right. So that's going to be union 2, comma, infinity. Then the interval, it's decreasing. It's decreasing from negative 1 to 2. It's only decreasing on that one interval, from negative 1 to 2. And then the local maximum, the high point is at negative 1. And it looks like 2, 4, 6 would be here. So probably 7. The max, Uncle Max is at negative 2, 7, and Aunt Min is at 2, x value 2, y value negative 20. So I have a f of x and I have a g of x for number 7. And my f of x is 1 over x. My g of x is 3x minus 1. And they want me to do fog. So all fog is taking g and plugging in the f. So basically fog is 1 over g in this case. So that's going to be 1 over 3x minus 1. And then it says write the domain. So the domain is not allowed to be 0 on the bottom for any fraction. So 3x minus 1 equals 0, 3x equals 1. So x is not allowed to equal 1/3. So everything but 1/3, and in interval notation that would look like this. Negative infinity to 1/3, union 1/3 to infinity. So I have this equation, f of x equals negative 2x squared plus 8x plus 10. And it wants me to find the vertex. It wants me to find the vertex. So in order to find the vertex without a calculator, I'm going to have to implement negative b over 2a, and that will give me the x value of the vertex, negative b over 2a. So negative b over 2a, b notice is 8, a is negative 2. So it's going to be negative 8 over negative 4. So the x value of my vertex would be 2. So now to find the y value of the vertex, I have to throw that 2 back into the equation. So that would be written as f of 2 equals negative 2 times 2 squared. Well, that's going to be 4. And 4 times negative 2 would be negative 8 plus 8 times 2. And that would be 16 plus 10. So this would give me 16 minus 8 would be 8 plus 10. So my vertex would be 2, 18. And as for the x-intercepts, in order to find the x-intercepts, I would have to set this equal to 0. So solving for x, that would give me negative 2x squared plus 8x plus 10. Set it equal to 0. I don't like factoring with a negative out front, so I'm going to divide everything, even the 0, by negative 2. It's going to give me x squared minus 4x minus 5 equals 0. And now maybe I can factor this. So it's going to be x times x, 5 times 1, because that middle term is negative, 5 is negative, positive. So the x-intercepts are going to be at x equals 5 and x equals negative 1. What else does it want? It wants the y-intercept. Y-intercept is pretty easy. All you do is look at that plus 10 in the back end. So the y-intercept is going to be 0, comma 10. So I have the vertex, 2, 18, negative 5, 0, negative 1, 0. I think there's a typo for her. Yeah, I think she has a typo here. And 0, 10.